Hola, buenos días, mis estimados. Espero que estén todo bien, todo azul. Vaya, de relajo ahí. All right. Today we're going to start with a heavy subject. In this case, actually, the last 2 weeks ago, we learned how the concept of the limit, and we learned how to calculate the limit in algebraical method at the same time with the limits definition. We learn how to calculate the derivative of the function, the derivative of the function, at the same time the slope of the line, the instantaneous velocity, and the instantaneous acceleration. That will be the derivative of the instantaneous velocity. Also, we learn how to calculate the limit of the infinite and how calculating the area of the graph by means of the limit definition. Today we're going to, again, we're going to apply the derivative of the function, but this time instead to use the limit definition, hija, guarda el celular, por favor. Gracias. The limit definition, this time we're going to apply rules or properties of the derivative. What is the definition of the derivative? The definition of the derivative can be or can be defined like a rate of change of any function. What that means, I have a question for you. If the derivative is a change of rate or a change of rate of the function, would you like to tell me what could be the derivative of any number? For example, if I ask you, what will be the rate of change of the number 5? Anyone, would you like to respond? What will be the possibility to determine what will be the rate of change of the number 5? Or number 6, -1/2, 0, square root 2. What could be the rate of change of that number? The answer is so simple. There is no rate of change of the number. The number has one singular value. 5 always will be 5, 0 always will be 0, -1/2 always will be 0. So according for this situation, in any number, for any constant, it doesn't matter if we have a whole number, fraction, negative, positive, rational numbers, the derivative of any number will be 0. That's why we're going to start with the properties. For example, properties of the derivative. Properties of the derivative. The rule number 1, or the property number 1. The property number 1, the derivative of C represents any constant, I mean any number, always will be 0. Rule number 1. Rule number 2, the derivative of the linear variable. It doesn't matter if we're talking about X, Y, Z, W, N, whatever you want, we're going to use X. The derivative of the letter X or any linear variable always will be 1. If I said, what is the derivative? Rate of change of X, what? Rate of change of W will be 1, and so on. Now, the rule number 3 is the basic rule of the derivative. The derivative of the X, variable X, elevated at the n power could be positive, could be negative, could be whole number, could be a fraction, it doesn't matter. That will be equal to the product between this exponent times the base, and the power of the base will be subtracting by 1. This is the golden rule and the golden ruler of this derivative. Again, you can the downward exponent multiplied by the base, and the base elevated at the n minus 1. Now, rule number 4, we're going to consider f dx and g dx like a two functions. For example, if I said, what will be the derivative of the function f dx who's adding or subtracting the second function ddx? If you're thinking, okay, this is going to be the derivative of f dx, positive, negative, the derivative of g dx, if you're thinking this logical sense, you're right. That will be the derivative of the addition or subtraction. Actually, this is the goal, the ruler of the addition or subtraction of the functions. The derivative of the first function as adding or subtracting the derivative of the second function. But what will be the change in this case? That will be, for example, in the problem, in the rule number 5, when we have the product rule between them. I mean, derivative GDX times the derivative of FDX GDX. If you're thinking, derivative the first one times derivative the second one, in this case, you're wrong because it has a, a golden ruler. And this the rule will be the first function, f dx, multiplying by the derivative of the second function that we call g dx, plus second function g dx multiplying by the first function f dx. Or simply words, the first term multiplied by the derivative of the second term, plus second term multiplied by the derivative of the first term. This is going to be the rule number 5. We learn addition or subtraction. We learn the product. And meanwhile, I'm going to show you how to apply the derivative of the quotient. I mean, f dx over g dx. If you're thinking, I'm going to divide the derivative of the numerator and the derivative of the denominator, you're grown again, because in the quotient or division, we have a singular golden rule. What will be that golden rule? Will be this one. The second term or second function ddx multiplied by the derivative of the first function f dx. Subtracting f dx multiplying by the derivative of g dx, and the entire equation divided by the second function g dx elevated out the second power. Okay, we're going to start with the basics 6 rules of the derivatives. Okay, derivative of the constant, derivative of the variable, a linear variable, derivative of one variable elevated to n power, and addition, subtraction, product, and quotient. Obviously, this is the algebraical derivative rules. After that, we're going to learn how to calculate derivatives of the logarithmic exponential function and also trigonometric functions. But these rules are, how to say that, and stick together with the next functions that we're going to learn. So this is the, how to say that, the strongest base that you're supposed to have. If you dominate the first rules, the first 6 rules of derivate, it doesn't matter. We're talking about trigonometric, exponential, logarithmic. You won't have any problems because the application will be the same. But that for that reason, you really need to understand how to apply at least the first rules of derivative. Now I'm going to show you an example. Example number 1. Find the derivative of function. Bueno, voy a cambiar de color porque este parece que ya murió. Okay, what function? If I said y equals 5x cubed minus 2x squared plus 3x minus 1. Okay. At the moment, I'm going to apply the derivate, I'm going to copy the letter Y over here and I'm adding a comma. In Spanish, you will read this one like a Y prima, prima, pero no prima de su prima, sino que prima, va prima como cuando usted anda adelante. In English, we're going to say prime Y, okay? No como, así como Optimus Prime, prime Y, or the derivative of the function, yes? Por eso, esta connotación que es la derivada. And you're going to read prime Y. How are we going to apply this situation? Simple. Derivative 5x cubed, what are we going to do? We're going to copy the letter 3, number 3, parentheses 5x, and this number 3 subtracting 1 degree. Rule number 3. And we got 3 parentheses 5x squared minus, same happened over here, 2, because this is the power, parentheses 2x. Why only 2x? Because 2 minus 1 will be 1. Plus, just as I said, 3 multiplying by the derivative of x. Remember what did I said? Derivative of the letter x will be 1. For that reason, 3 multiplied by 1. And tell me, what will be the derivative of -1? Will be 0. Rule number 1, derivative of the number. It doesn't matter, positive, negative, whole number, decimal, fraction, whatever you want to say. The derivative of the number will be 0. What will be the answer? Y prime will be equal to 15x squared minus 4x plus 3. And this is going to be the derivative of this function. Questions? Questions?
Mister,
Mm-hmm.
what rule did you use for the 3x?
Rule number 1. Derivative the letter x, that will be 1. Or if you wish, you can modify this one like derivative cx, if you want to say that one, that will be c. Well, that will be easier for us. For example, we got derivative 3x, that will be 3. If you want to consider this and this rule, okay? Second example, if we have f dx equals 5x4 minus 2x cubed plus 5x. Okay, we really need to derivate the function. Now, f prime x, if you see f prime x, that will be equal to 4 parentheses 5x cubed minus 3 parentheses 2x squared plus 5 derivative of the x, that will be 1. So the answer will be 5 prime x equals 20x cubed minus 6x squared plus 5. This is going to be the solution set of the second example. Understood? Understood?
Yes, mister.
Okay, we are applying addition and subtraction. But how about when we got the product? Well, this case, we have GDX. GDX equals parentheses, 2x squared minus 3 multiplied by 3x squared plus 5x plus 1. Okay. As soon as you can see, we have a product, right? So if you see the rule number 5, we have a productive function. We're going to consider the first term will be 2x squared minus 3, and the second one will be 3x squared plus 5x plus 1. We must follow the rule of let me move the camera, sorry. We must consider again the rule number 5, the product. The first term f dx in this case will be 2x squared minus 3. And the second one, what we said, gdx will be the second term, 3x squared plus 5x plus 1. We must apply the rule number 5 just like this one. First term times the derivative of the second one, plus the second one times the derivative of the first one. It's in simple merely words. So let's see what we got. G prime x equals first term 2x squared minus 3 times the derivative of this one. All right, I'll do it quickly because I think you're understandable how to apply this rule. There will be 6x plus 5. First term times the derivative of the second one, plus the second one times the derivative of the first one. What is the derivative of 2x squared minus 3? Simple, that will be 4x, right? Because negative 3 is the derivative of the number, that will be 0. So that will be 4x. All right. First term times the derivative of the second one, plus the second one times the derivative of the first one. And because we got the derivative already, we won't leave the answer just like this one, right? The only thing that we must do is applying this theory property, like terms, and that's it, as soon as we can. So g prime x will be equal 2 times 6 will be 12. 12 what? X cubed. 2 times 5 will be 10x squared. Negative 18x. Negative 15 plus 3x squared. Oh, sorry, plus 12x cubed, right? Plus 20x squared plus 4x, right? And applying the like terms, let's see what we got. We got 12 plus 12 will be 24. 24 what? X cubed. 10 plus 20 will be 30. 30 x squared. Negative 18 plus 4 will be negative 14x. And finally, minus 15. And this is going to be the solution set of the product. Understood? Remember, this function given in red line are represent the derivative of the function 3x squared plus 5x plus 1, and another one will be the derivative of that function. When you got those derivatives, the only thing that you have to do is multiply, like terms, and that's it. Questions? No hay preguntas. Seguro, no hay preguntitas, preguntas para nada.
Mister,
Ujú.
o sea, es que ya, o sea, todos los demás le entendí, Pero es que ya ese último me perdí, la verdad. O sea, no le quiero explicar así como por parte.
Bueno, no hay problema. Mire la reglita otra vez. Otra vez. Vamos a ver la regla número 5. Mire, ¿qué dice la regla número 5? Este es, ponga que f de x y g de x sean dos términos, primero y segundo. Primer término por la derivada del segundo. Mire bien, primero por la derivada del segundo. Vamos para acá. Fíjese bien que no es complicado, solo es de fijarse en la tonalidad. Recuerde que este es el primer término y este es el segundo. Primero, por esto que está aquí es la derivada de este. Derivada de 3x cuadrado es 6x. Recuerde que se multiplica el 2 por el 3 y este 2 se le resta un exponente. 5x es lo que le habíamos dicho de esta parte de aquí. Y usted tiene cx, la derivada es c. Y la derivada de 1, como es una constante, es un 0. ¿Hasta aquí estamos? Hola, ¿estamos hasta
Sí,
aquí?
pero ahí sí,
Bueno,
ahí sí.
bueno, más. Vamos a la regla otra vez. Mire bien, ¿qué dice la regla? Más el segundo por la derivada del primero. Ok, ponemos hasta acá. Más el segundo por la derivada de este. Recuerde que este es 2 por 2, 4x. ¿Por qué solo 4x? Porque el 2 se le resta 1. Y la derivada de menos 3 es 0. Y esto, este rojo, este primer rojo de aquí, viene siendo la derivada de este. Y este segundo rojo viene siendo la derivada de este elemento. Ya una vez que ya derivó, el resto es pura álgebra. ¿Hoy sí?
Sí, mister, ya. Gracias,
Bien.
mister.
El secreto es, muchachos, mi recomendación es que esas derivadas se las aprendan como la tabla del 1. Si usted se sabe las reglas de la derivada de memoria como la tabla del 1, le ponga lo que le ponga, usted va a derivar. No se la sabe, usted está acabado. Así de sencillo, no va a hacer nada. Ni las manos va a meter. Le va a pasar las del Barcelona con el Bayern, cuando le metieron 8-2, ni más ni menos. Entonces, hay que aprenderse esas reglas. Por eso es que estoy haciendo hincapié con las primeras 6, porque esas 6 se aplican para todas. Another example. Y equals 3x minus 5 over 2x plus 6. Obviously, we have a quotient, right? Rule of the quotient. What the rule of the quotient says. Upward first term, downward second term. First one, derivate of the second, second one, derivate of the first one, minus first one, derivate of the second one, the entire expression divided by second one at the second power. This is a given rule. So at the moment I'm going to apply, remember this is the first one, this is the second one. So what we got? Y prime or prime y equals second term times derivative of the first one. What is the derivative? 3x minus 5 will be 3. Perfect. Will be 3 minus y minus, because the rule says second term times derivative of the first one, minus first one, parentheses, 3x minus 5 multiplied by the derivative of the second term. What is the derivative? 2x plus 6. That will be 2. Perfect. That will be 2 because derivative 2x is 2, derivative 6 was 0. The entire expression divided by the second term elevated at the second power. Why? Because the rule says that. Please avoid the temptation from trying to cancel. You cannot cancel because there's a subtraction. The only thing that we have to do in this case is applying the sterility property and apply like terms if we can. I mean, y prime says equals 6x plus 18, right? Minus 6x, okay? Plus 10, the entire expression divided by 2x plus 6 second power. Remember, 2 times 3x positive 6 times negative x. 2 times negative 5 is negative 10 plus negative, that will be positive. And as soon as you can see, we have like terms 6x minus 6x, and we got 18 plus 10, that will be 28 over 2x plus 6 elevated of the second power. And that's it. That's all that we have to do in this function. Questions?
Mister,
Mhm.
también, ¿lo tengo que dejar así o tengo que resolver para la parte, para el binomio de abajo?
Mire, podríamos resolver el binomio de abajo si en algún caso pudiéramos simplificar, pero si no hay nada que simplificar, no hay, ¿cómo se dice? Objeto en hacerlo.
Ok.
Solo la idea de la derivada es simplificar. Si usted mira que en lugar de simplificar va a tener usted un semejante molote, déjelo así. ¿Ok?
Ok.
And we have some kind of applications. For example, do you remember a few weeks ago, I'm going to move the camera a little bit to the right side. And I'm going to apply some applications. For example, we got the classic one. Find an equation of the line that passes through the function f of the x equals 3x cubed minus 2x plus 1 at the point -1, 2. Actually, that was one of those problem applications when we calculate the slope of the line using the limit definition, right? Okay. In this case, I have a good news for you. You don't need to apply the limit definition to solving this problem. Always the derivative of the function gave us the slope of the line, the first derivative. So we got the function f of the x equals 3x cubed minus 2x plus 1. So f prime x, all right, would you like to tell me what will be the derivative of that function? If did you understand the concept? 9x what? 9x what? Square, right? What else? And that's it. Because the derivative of number 1 is 0. Perfect. The derivative of the function is 9x squared minus 2. Okay, this is the derivative. For that reason, if you really want to know what will be the slope of the line, mdx equals 9x squared minus 2, I'm going to evaluate the letter x by the point located over there. That will be -1. I mean, m times -1 equals 9 times -1 second power minus 2. So this slope will be 7. In simple mentally words, the slope of the line will be equal 7. So what will be the equation of the line? Remember, the equation of the line formula is given by y minus y1 equals m parentheses x minus x1. So let's apply y minus 2 equals 7 parentheses x plus 1. Y equals 7x plus 9. And this is going to be the equation of the line. Why 9 units? Because 7 times x, 7x plus 7 plus 2 will be 9. Actually, you can solve this problem using the limit definition. Why are you laughing, usted, Santiago? ¿De qué ríe? Ah, ya me di cuenta. Eso está como para enmarcar. Tómele una foto y mandémosla al grupo. ¿Verdad que sí? ¿No? Mándalo al grupo de recuerdo. Bueno, entonces, muchachos, no sé si hay alguna pregunta hasta ahorita o está todo claro. Hello.
Está todo claro, Mr.
All right. Tomorrow we're going to solve a few applications of our mini word problems that we want to apply the equation on the line, how to calculate the instantaneous velocity, the instantaneous acceleration, just like in physics problems given by the parametric equations. We call this one the parametric equations because we're talking about equations that represents height, velocities, or accelerations in function of time. Normally, we are solving those equations by means of the limit definition. But this case, instead to use the limit definition, we're going to use the properties of the derivatives. Okay? If there are no doubts and questions, see you tomorrow. Well, I'll see you on physics class in God wills. Take care of yourself.
Bye,
Bye-bye.
Mr.
So long. Take care of yourself.